is scheduled 11:40, yeah? 35. Hello?
Sir, 12:30.
12:30. Okay. 12:30 or 12:40?
12:30, sir.
12:30. Okay. So how long the test is? 20 minutes, huh?
Yes, sir. 20 minutes.
Yes,
Okay.
sir.
Yeah, right. Okay. Yeah. So yeah, let's start, and in the meantime, the others can join. So as you know that yesterday I have sent an email regarding the tomorrow's class. Actually, tomorrow is the convocation day, 66th convocation, and on behalf of that, the classwork has been suspended for all the classes. That was the circular we have received. So therefore, I just sent an email that tomorrow there won't be any class. As well, there is no the exam also. We have scheduled the exam, and this exam, this is the second time it is like rescheduling. But anyway, we'll go with that. So tomorrow there won't be any class, and as well there is no test also. And yeah, that's what I communicated through email. And so our next class will be, and again, in the March first week, you have some semester break was there, like a spring break, right? That was there in the institute calendar. So is it, are you aware of that?
Yes, sir.
Yeah, right. So it start, I think the next week, the first 3 days up to Wednesday seems to be like March 4th or so. So therefore, even the next week also we'll lose the class. Fine, it's okay. So then the next meeting will be, or the next class will be like on March 9th, 9th of March. And I just checked the number of slots. Actually, we'll get maximum, I think there are 5 more Tuesdays, because the last one will take the exam anyway. So therefore, 5 or 6 weeks maximum. 6 Tuesdays we will get. So we'll see that to the whatever we can cover the syllabus. We'll try to do that. We don't go with a hurry because of this situation, right? So that's about the status of the classes and all. So the next class will be on 9th March, and there will be a quiz as one, and for that quiz the syllabus will be whatever I have already mentioned for this quiz about to hell, plus the contents that will cover today's class and all. So it's basically, it starts from the process creation, and then the like inter-process communication, shared memory, and today's content like message passing and so on. So these were the contents for the next quiz. So please follow that. So next I'm just sharing the presentation, and then we'll quickly go through the today we'll try to discuss about the inter-process communication. So in the last class we started, I just introduced the inter-process communication, and so in the last class we discussed about one of the scheme or one of the mode of inter-process communication, that is by using shared memory. Okay, and today we'll try to discuss about the other mode of inter-process communication, known to be message passing and all. So in the shared memory, as we have discussed that like the process which want to communicate, and also first of all they will create some shared memory segment, and then afterwards the process will map their memory to that shared memory, and with that the process can able to communicate with each other. That means the process can able to, that means the multiple process can able to access the shared memory segment, and with that they can able to write, read, and down. And the advantage of the shared memory thing is that shared memory way of inter-process communication was the communication was faster, because the moment once the memory segment was created and mapped to the individual process, then the communication will be like the normal way of memory access and all, like reading, writing the memory in the own memory kind of a thing. So that way it will be very fast. But the problem is that since the multiple processes are sharing a memory, that means sharing the object and all, then they should be careful. That means there should be coordinate and they should synchronize their actions and all. So that's what here in the first point, I just to recapitulate that, I just mentioned that. So in the case of shared memory, the mechanism for the process to communicate will be done by using they have to coordinate and synchronize their actions and all. Because the same memory segment will be like accessed by the multiple process and all, they should coordinate and they should synchronize. Otherwise, there will be the data inconsistency problems will arise. So whereas in case of message passing system, as I mentioned, that a process will communicate with each other without resorting any shared variables and all. So that way there won't be a issue of the data inconsistency and all, because here in case of message passing system, the communication will takes place by using the control of operating system by using the system calls, as mentioned over here. You can see that using the send and receive system calls, the message communication will takes place between the process and all. Right. So we'll see that how these send and receive system calls will be used. There will be variations of that depending on the various message passing schemes and all. And as I mentioned here, the size of the message can be either fixed or variable. And again here, by choosing the appropriate action, appropriate option, suppose we choose a fixed message and all, then like implementation of that at system level will be easier and all, because all messages are fixed in nature and all. Then the corresponding writing the system calls and the implementation of that will be easier. But at a higher level, at a user level or at higher level, it will be hard because we need to constrain to pass the messages by the process of a fixed size and all. So that way it's a difficulty at a higher level. So therefore, if you use the variable messages at higher level, then it is more flexible. But at the same time, while writing the system programs or system level, you have a difficulty in handling the variable messages and all. So that's why it has its that means you will get a flexibility either at the higher end or at the kernel level and all. If you want to flexibility at or more convenient at a kernel level, then you have fixed messages are preferable, or otherwise if you want to have more flexibility at higher level, then the variable messages are preferable. Okay. Yeah, then coming to the message passing, suppose you want to pass the messages, or if you want to communicate between the two processes P and Q is to communicate. And in case of message passing scheme or for anything, you need to have some communication link has to be there between the processes. And we'll see that what is the communication link or what are the issues in that, in establishing that, and how to use that. So those things we'll brief it later. And then once the communication link was there, then afterwards by using the send and receive message calls, system calls, you can able to transfer the messages and all. And the implementation issues are, as I mentioned here, first of all, how the links were established, right? And then can the link can associate, that means how many processes can be associated with the link? Is that only two processes or more than two processes? Or likewise, how many links can be there in a pair of communication process? That we have a processor there, we have a pair of process want to communicate. Is that pair of process contains only one link, or like there are multiple links? And what will be the capacity of the link, right? Capacity of the link means what is the carrying capacity of the link, like how long messages are can be transmitted, how fast you can transmit, that will be the capacity of the link. And yeah, again, the same thing similar to that is the size of the message that the link can accommodate fixed or variable. That means whether the links carry the fixed or variable messages, or the links are unidirectional or bidirectional. Let me suppose we have a communication link between the two processes, whether the two processes can communicate simultaneously. It means that both can able to send simultaneously. So that's what I mean by unidirectional or bidirectional. We'll see the details. And coming to the implementation of communication link, again, the implementation of communication link, there are two aspects of that, the physical aspect and the logical aspect. The physical aspect means how physically the communication link will be established. Like we have seen already, like having a shared memory is one of the ways, and then using a bus like a proper connectivity. And then suppose the processes are on the two different machines or two different systems which are separated. So in that case, by using through network, you can have a communication link will be established and all. Because the processes are there on the two separate machines and on the two different networks or whatever. So in that case, if we want to have a communication, then in that case, the link will be realized by using the path through a networks. And in the case of logical way of communication link will be like whether it's a direct or indirect, we'll see the details later. Like whether the communication link will be incorporated or it's a direct or indirect. And is it the synchronous or asynchronous way of this one, or like whether the buffering is that explicit buffering or automatic. So these details we'll see when you go to the corresponding slides. You can get a clarity about what is meant by direct, what is meant by indirect communication link and so on. So first we'll see the direct communication. So in case of direct communication, what it means here is that, so here the communication will takes place by using the process identities. So it means that directly if you want here the send and receive message system calls, they use the directly identity of the process directly, the P and Q. These are the process names, and then with the process names, the communication will takes place. It means that while sending the message, along with the message, it also informs, it also indicates the who is the sender of this message. They'll send message to process P. It's not sender, it's a receiver. Who is the receiver, where the message has to be sent. That means who is the process, who is the message from where the message is targeted for. And likewise, in the case of while receiving the message, where the receiver will expect that where the message is coming from, like receive a message from the process queue. It means what it means here is that in case of direct communication, the process identities or the process names will be directly used for communicating the messages and all. That's why it's known to be the direct communication directly by using the process identities. And as you are using the process identities directly, so therefore the links will be established automatically. There is no need for establishing the separate links, and big since we are giving the names of the process directly. So with that, the links will be established automatically. And then afterwards, once the link is there, the link is associated with exactly one pair of process, because you are specifying that you are sending a message, and then the receiver is also says that it is receiving message from a particular process and all. So therefore, a link will contains only exactly the pair of process, two process, and between a pair of process, only one link will be there, and a link may be unidirectional or bidirectional. Unidirectional means like the communication will be only one direction. That means a P is sending the message and Q will be receiving the message. Whereas the bidirectional means if both can able to do that, if the P can send a message to Q and as well the Q can send a message to P, then it is known to be bidirectional. And these are the various like you can say that the issues are you can say that the specifications where the operating system should the design to take care about the establishing the links and then to have a communication through the links and all. So whereas if you see, this is the direct communication. When you come to the indirect communication, so here the communication is taking place via mailboxes, through mailboxes. It means that there will be one mailbox and then the process will attach to that mailbox, and through that mailbox the process will send the message and receive the message. So here the messages are like directed or transmitted and received from the mailboxes, through the mailboxes, also known to be ports. Also these mailbox also will be referred to as ports with some port IDs, port numbers. And here each mailbox has a unique ID, as I mentioned, and the process communicate only if they share the mailbox. Suppose the process want to communicate, then both the process, they should have some shared mailbox has to be there. Then only the process can able to communicate. Yeah, it is like intuitive also, because if they have the shared mailbox, then with that one process will place the message into that mailbox, and the other process can access that message through that mailbox and all. And then here the communication link will be like here what are the properties of a communication link. Earlier when you see the direct communication, we have seen the properties of communication link. Like that means we have in a pair of process, we have only one link will be there. And then again for a link, again, only two processes will be there. So that way there are certain properties. So here in the case of indirect communication, that is through mailboxes. So here the properties of the communication links are like some of these are here given below. Link established only if a process share the common mailbox, as I mentioned, because a process want to communicate, those two processes should have access to a common mailbox. Then only the communication will take place. And the second point here, you can see the link may associate with the main process. Many process. It means that suppose you have a mailbox is there, and then that mailbox can be shared by the multiple process, not only the two process, can be shared by the multiple process. So that's what I mean by the link may be associated to many process, right? We have a mailbox, and that mailbox can be shared to the many process. So then it means that here in this case the link can be shared by the multiple process, not the exactly the pair of process. And here each pair of process may share the several communication links. That also possible. It means that you have a process, you have a pair of process. That pair of process may share the multiple mailboxes. It means that you have a process P, for example. It can share or it can be connected to a multiple mailboxes and all. Sometimes it may use the mailbox, so for example A, and sometimes it may use the mailbox B. Sometimes it will use the mailbox C, and so on. So therefore, that means each process may be connected to multiple mailboxes. So therefore, a pair of process can share several communication links, and depending upon at that particular point of time, if the two process they decide, then based on that, through particular mailbox, they can able to carry out the communication and all. And again, the link may be unidirectional or bidirectional. It means that through the same mailbox, either the link can be unidirectional or bidirectional, can be possible. So these are the various things, and in the indirect communication. And then coming to the operations in the indirect communication, because in indirect communication, the heart of the communication is the mailbox. It means that through mailbox, the communications, the messages will be transmitted, received, and all. So therefore, here the operations related to that mailbox for that communication will be creating a mailbox, new mailbox, and send and receive messages through mailbox, and then the destroy mailbox. So these are the basic operations that will be there in case of the indirect communication and all. And then coming to the system calls over here for sending and receiving a messages and all, same send receive is system calls. But here this A is nothing but a mailbox. That means you are sending a message to this particular mailbox, and then you are receiving a message through this mailbox and all. So it means that whichever the process, if they want to communicate, they should have some common mailbox, and then with that mailbox, the message will be communicated. The message will be shared. Yeah, this is the scenario. You can see that suppose there are three processes P1, P2, P3, and if they share a mailbox here, and in that case, suppose the P1 sends a message, then the P2, P3 can receive. But who gets and who is the intended receiver and who want to receive? So in that case, there are different solutions are there. So one way is that actually allow the link to be associated to at most two process, right? That means you have a mailbox, and the mailbox will be shared by only exactly two process. So in that case, there won't be any ambiguity because there are only two process, and if one process sends, the other process can receive. Or otherwise, the other options are like allow only one process to execute the receive option, receive operation, or receive system call. So here in this case, suppose the P1 sends and the P3 both can receive. So here at any point of a time, only one of the process can be allowed to execute the receive system call. And or otherwise, you can allow a system. That means maybe the operating system will decide who will be the receiver and all for that particular mailbox at that particular point of time, and then sender will be notified accordingly. So therefore, because all these things are actually when you go for indirect communication, you have a various options will be there, and the different operating systems will execute or will perform, will provide the different facilities to have a communication between them. And the another way of the communication, the message passing will be not another way, like in that there are like another mode of this will be like a synchronization. And here the synchronization means actually here basically deals with the message passing will be either blocking or non-blocking. So it means that blocking, non-blocking means when you go through that, it will be clear to you. Blocking means suppose a process sends a message, and after sending the message, it will be blocked. It will be blocked means it will just wait for the acknowledgement from the receiver kind of a thing. And as long as the acknowledgement doesn't arrive, it just keep on blocking, keep on waiting for the acknowledgement. It means that the process, the sender, after sending the message, it will be blocked. And it is just waiting for a reply from the receiver saying that the receiver has properly received the message and all. So that's not to be the blocking send or a block send system call and all. Similarly, the blocking receive system call. So what it means is that here the receiver will be blocked until a message is available. Because you see that here these things, here this indirect communication, the message communication will takes place through mailboxes and all. And the mailboxes are nothing but it's a kind of a port. You have a port will be there, and the sender, if you want to send a message, then the sender will pass the message to the port and just keep on waiting for until again the acknowledgement or the message received from the receiver and all. Likewise, the receiver also it will be waiting for the message to be received from that particular port, and then keep on waiting for that. And if the message is there in the mailbox or in that particular at that particular port, at that particular queue, it will receive the message. And if it is not there, then it's keep on waiting for the message will be available at that particular port, at that particular queue. So that way, no, the thing, the blocking means here, both the blocking send, blocking receive means the both sender and receiver can execute the blocking send and receive system calls, so that the message will be sent and then message will be received. And so this is known to be the blocking send, blocking receive. And there are other way also, then other than the blocking, known to be non-blocking way of handling the send and receive system calls. And here in case of non-blocking means the sender sends a message and then it won't wait for that, and that will continue for the other its other things. Likewise, in case of receive option also, non-blocking, the receiver executes the receive system call, and if there is any message in the mailbox or in the queue, it will receive a valid message. And if it's not, if there is no message in the mailbox, and then it just receives a null message kind of. That means there is no message and all. Then again, after some time, then again it tries to access the mailbox for receiving the messages. If there is a message, then it will accept, and otherwise it will receive this. It will receive the null message. So that way, and then again, there are different combinations are possible, like blocking send, blocking receive. There are like blocking and non-blocking, different combinations are possible. And if both send and receive are blocking, that is known to be like this one religiousous way of data transmission. That means both are blocking. It means that in this case, actually, you don't need a buffer also sometimes, because the sender sends a message and they keep on waiting for the reply and all, the acknowledgement from that. If the acknowledgement arrives, positive acknowledgement, then it's fine. Otherwise, just wait. And if it is received negative acknowledgement, then again it will send the message. That is the way. And yeah, these are the like the simple code for this particular send and receive system calls for the particular indigenous way of transmission. That means both are blocking. It just sends and blocks, and then it just receives and then block. And then coming to the buffering, again, there are buffering means basically here while sending and receiving the messages and all as a mailboxes, whatever. It's nothing but it's kind of some buffer will be there, some kind of a queue will be maintained by the operating system or a particular process and all. And with that, the message will be transmitted and all. So zero capacity means there won't be any buffer at all. That means the message will not be queued at all. The sender will send and then the receiver has to receive that one. That means here, since there is no like the message queues or message buffers and all, so therefore here the sender must wait for the receiver and all. That means both the sender and the receiver has to be like execute the blocking system calls so that the communication will takes place properly. Whereas the bounded capacity means here you have a message box or you have some buffer will be there, And then through that buffer, the sender will send the message and the receiver will receive that one. And since there is a bounded buffer, so therefore, suppose if the buffer is full, for example, then the sender must wait. A sender should be blocked. If the buffer is full, then the sender should be blocked until there will be some free spaces available so that the message will be placed into that. So likewise, and similarly, the receiver also, if there is a message, then it will receive. Otherwise, if it is a blocking receiver, then it has to wait for some message will be arrived and all. And where, for example, unbounded capacity, it means that assuming that we have like the buffer, there is no limit on the buffer available. So in that case, the sender need not be blocked at all because all the time there is a buffer available. So therefore, the sender, whenever it has a message, it can able to place it. But the receiver has to be blocked because there is no, if the entire there is no messages or if the buffer is free, if the buffer is empty, entire thing is empty. So in that case, the receiver has to wait. So that way, I can say these are the various ways of like if you want to implement the indirect communication, then these are the various aspects or various issues one should worry about that. Or so first thing, as what we had discussed, direct and indirect communication, and then afterwards synchronous and asynchronous way of message passing, and then the different ways of the buffer maintenance, like zero buffer, finite buffer, and the infinite buffer. And these things are some of them, like infinite buffer is the idealistic one, like and yeah, I think we'll now it's 12:30, so we'll stop here because the later part will be here. The like an example of this message passing system supported by the like this operating system, Mac operating system. And so these are the various system calls that are used, like message send, message receive, and message RPC. Anyway, so so yeah, since you have exam at 12:30, so we'll stop here. Okay, and so our next class will be, let me see, come back. Okay. So our next class will be on 9th March, and as I mentioned in the this one, and the syllabus will be till whatever I have covered today, plus the previous syllabus as I already mentioned in the mail and all. So we'll meet again on March 9th and prepare for the test also. Okay. Yeah, I will stop here. Let me stop the recording and okay.